As we look out in space, we look back in time. And today, with large telescopes on the ground and with space telescope, we can look at galaxies as they were 5 billion, even 10 billion years ago. Very near, galaxies which are very young. And we can see, in fact, we can measure from the ground how galaxies were distributed. So the historical record is there for us to observe.
The Hubble Space Telescope is probing regions billions of light years away, when the universe was far younger than it is today. There, galaxies have blotchy, distorted shapes. They are pocked with the bright blue signature of myriad stars being born.
One of the most exciting things about these really distant galaxies is that they look quite different from nearby galaxies. They look very disturbed, very irregular. And then there are all these little specks, tiny specks and blobs that don't look anything like galaxies nearby. Those are probably the little bits and pieces, the little building blocks, the little galactic Lego pieces out of which galaxies were forming at a very early time.
Today, astronomers are using Hubble to extend the very limits of what we can see. Mark Dickinson studies the origins of galaxies.
It's a great time to be an astronomer because you have new tools like the Hubble Space Telescope to study extremely faint objects which can't really be probed in any other way.
Dickinson led one of Hubble's first projects after the repair. He and colleagues discovered a group of galaxies 8 billion light years away. It was, for a time, the most distant cluster ever glimpsed.
He took us to the airport.
Now, he is part of an ambitious new venture known as the Hubble Deep Field. The project will zero in on a tiny patch of sky near the Big Dipper that is no larger than a grain of sand held at arm's length. To most ground-based telescopes, the target area appears utterly void of galaxies or stars.
The idea of this project is to go as deep and faint as the telescope can be pushed to go and see the faintest galaxies. Those don't even show up in individual exposures for the most part. They're so faint that there's not enough light for them to record an adequate signal on one exposure. But this is one of 50 or so that we'll be taking through, say, this one particular filter over the course of 10 days.
Do you always display it linear as opposed to, have you tried log or square?
The project has drawn a team of astronomers from around the world. Already, images of distant galaxies are beginning to take shape.
This one I would have thought is a spiral.
Yes, but it has no nucleus, and or several, or extremely.
They're counting on this venture to shed light on how the universe and its galaxies evolved from the earliest times.
It would be hard to imagine a galaxy would end up looking like that.
The question is, just how deep in the universe has Hubble delivered them?
That is really a great part of the field.
Now we can build bigger and bigger telescopes and see even farther out into space. And the limits of how far we can see galaxies now are about 10 or maybe 14 billion light years. This is assuming that the universe as a whole is about 15 billion years old. So the farthest we could see is 15 billion years, because that's all the time that light has had to travel. And that's the edge of our visible patch. It's called our horizon.
For now, it seems, Hubble's view of that horizon is obscured.
Some things change from exposure to exposure, which are all the cosmic rays. And by filtering, by comparing at a given position and throwing away anything that strongly deviates, you remove the cosmic rays and end up with a combined image that looks like this. And that's the basic cleaning process that we do.
Scatter light getting into the telescope.
Then there's glare from the sun.
We're going to try subtracting out these patterns independently.
At last, the team begins its major work to enhance details within the In the coming days, they'll overlay the varying images and refine them pixel by pixel.
But I think they'll go.
I take one picture like this, shift a millimeter, take it again, shift a millimeter, take it again. So I'm taking the same picture, but it's slightly different positions, so I get a better sample.
Right. If you've ever,
and then you combine the information from all of that, and you get a better resolution. Is that sort of roughly right?
Right. If you've ever watched on television when they black out someone's face, they put on these large pixel squares. And we have something like that. We have a face blocked out by large pixel squares. And if someone gave you the original videotape with those large pixel squares, you could, using a technique like this, reconstruct that person's face.
Barely a month after the Hubble Deep Field began, it's time for the big unveiling. In recent years, the annual gathering of the American Astronomical Society has brought a series of extraordinary revelations. This year, the deep field is center stage. It's an hour before curtain. What better time to address an important question? How many galaxies are there in the universe?
I like the 100 billion because it's like roughly the number of stars in the galaxy. But I think we better not push our catalog verbally too far.
It boils down to simple math. Take the number of galaxies in the deep field and multiply across the full extent of the sky, give or take a few billion.
So we're talking about 50 billion across the sky, roughly.
The winning number? 50 billion galaxies.
This is a large blow-up of it done by a photographic lab, in which you see a very small region of the sky, 10 days of exposures, and you can see a myriad of galaxies. There are roughly 1,500 of them.
As Bob described, this is a basically blank patch of the sky, which if you look at it with a modest-sized ground-based telescope at one of the sky survey prints, you see almost nothing, 1 or 2 galaxies. The statistics, the sheer numbers are impressive, but by itself, that's not really enough. We can count the galaxies in this image and say, my God, there's a lot of them, but we don't know what they are. We need to understand what these galaxies are. We need to understand how far away they are, what their properties are, before we learn anything about galaxy evolution from a picture like this.
Now revealed in stunning detail, the distant frontiers of time and space. The early universe, it seems, is a jumble of twisted shapes and cosmic question marks. Ultimately, though, the deep field is simply a flat portrait. Which of these galaxies, astronomers want to know, shine from the limits of the visible universe? And what milestones in galaxy formation do their shapes reveal?
In many ways, what we have here is an archaeological dig, the deepest archaeological dig ever done. And we're left with a good view of the colors, the shapes, the sizes of all the relics, but we don't know the layer of dirt from which they came.
How far away are these things? Are they little dwarfs nearby? Are they star-forming protogalactic subfragments? What are they? Well, we'll try to find out eventually, and that's what this is meant to be a resource for.
For all the unknowns the deep field presents to astronomers, to the public, it's sure to be a revelation.
I think it's one of the most important things that the Hubble is doing. The picture is stunning, and we'll probably want to run that and then await the scientific analysis and then report on that.
Huge numbers here, billions of light years away, billions of years ago. billions of 100 millions of light years across, seeing things I've never seen before. This is easy. This is like candy to a science writer. This is easy. This is like falling off a log.
The deep field goes on view like a grand work of art snatched from space. Measuring the distance to its galaxies, the same work that once consumed Edwin Hubble now awaits astronomers lining up to study it. They will peer for the first time into this narrow celestial corridor. On Hawaii's Mauna Kea volcano is one of the largest and most sophisticated telescopes on Earth, the Keck Observatory. Tonight, a group of astronomers has come to pinpoint the most distant galaxies in the deep field.
Probably 5 minutes.
Okay.
Sandy Faber leads the team.
So you're gonna.
My own personal hope for the Hubble Deep Field is to identify the moment of the beginning of galaxy formation. What were the first proto-galaxies like? How big were they? How did the stars form in them? We're looking back to an era when the universe and the galaxies in it were really quite different from the ones we see today. But not totally different. We can see a relationship. These are infant galaxies and adolescent galaxies compared to our own mature galaxy today.
Faber and her team are looking for galaxies 10 to 15 billion light years away. These appear as tiny blue lights in the deep field, shining faintly among the larger, brighter ones. To capture the light of these distant gems, they'll isolate them in a series of slits.
These labels tell us what to expect if we're lucky, and everything that says HZ means very high redshift object. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible very high redshift candidates on this mask, which makes it an exceptionally rich mask for very, very distant galaxies.
Keck is one of the most complex instruments in all astronomy, but rarely has it been pushed this far. Ed Groth is one of Faber's collaborators.
It's wonderful. I just can't believe that I get to come up here and use it. It's really a rush.
Still, Keck is only 3 years old, and it has a few kinks.
We think that this particular grading setting is an optimum for finding our high redshift distant galaxies. Which way is our compass, Rose? It says that we're
at minus.
See, I'm a little bit
154.
irritated at the quality of those images.
Yeah.
I don't think that's a wonderful image. Yeah, it's not. That ain't wonderful. That looks like telescope.
Inevitably, time is lost to calibrating the telescope.
That ain't good. At Keck, we're at 14,000 feet. We don't think very well at that altitude. Every moment of telescope time is precious. You prepare intensively to go there. It's easy to make a mistake and waste time during the run that you have. It's just like a time warp. It's living very, very intensely for a short period of time. It's thrilling, really.
We've got the offset applied. Wait for a few seconds. Okay, start the exposure.
Wow, Drew, that's our best alignment yet. Every star's in the middle of the box.
And the star images look pretty good too.
Each of these galaxies is 100 million times fainter than you can see with your naked eye. And they're hard even for this big telescope.
At last, Keck captures its first flickers of success. The spectral barcodes of these galaxies hardly seem as impressive as Hubble's pictures, but to the trained eye, they're nothing short of sensational.
There's a really nice continuum in that object there.
Here, you can also see one here. I'm running the cursor along it.
Yeah, I see that.
That's
That's
correct.
Okay.
What about there?
Ah, yes. Because see, we saw something.
Yeah, exactly.
That's
Yeah.
it.
That's
That's it.
All right. Looks good.
In the span of a few nights, Faber and her team record no less than 3 new high redshift galaxies. Each is fully 90% of the way back to the edge of the universe.
We've discovered a couple of new, really very distant galaxies in the Hubble Deep Field. We've probably got 3 or 4 redshifts above a redshift of 3, which means that we're looking back maybe 12, 13, 14 billion years. So those are among the top record holders. That's what we were really after in that field, was more like that.
As we peer ever deeper into space, how long before physical law itself blocks our vision beyond?
We know that there is a boundary to the universe that we can see. We call it the observable universe. It's how far a light ray can have gone since the beginning of time. We think that that observable universe is embedded in a much, much larger universe upon which we can make no observations because of the finite speed of light.
My response to the universe is complicated now, and it's really determined by the fact that I personally, not for scientific reasons completely, partly emotionally, think that there are lots of universes. I think that they might all be mostly different in terms of their physics from our universe. I'm thinking now of our universe the way other cultures might have thought about the nourishing Mother Earth. And in some sense, we truly belong here because we were produced by the physics here.
Overhead, the universe is expanding relentlessly, but not too fast for a father to share its wonders with his son. The Texas Star Party is in full swing. Don Garland built this telescope for 10-year-old Ian.
We'll slip this right in there. Which way does this need to face?
Tonight, at their 10th Star Party together, they are ready to give it a test run. It may not be Keck, it may not be an orbit, but for a young astronomer, it's state-of-the-art.
What do you want? Say right up here?
Yeah.
Here you go. And just push in. Got it. You want to look at Venus first?
Yeah, where is
Since
it?
it's up?
Oh, there it is.
It's
over
right there. To find it. Guess what? There it is. Oh, what a great view.
It is?
Yeah.
Let me see.
All right.
It's my telescope. Oh, wow.
First object viewed astronomically through the telescope is Venus.
It's a rainbow, all right.
Yep.
Ian has a long life of stargazing before him, but tonight will be hard to beat.
It's definitely
When I see gas clouds, I see these little globules of stuff up there. What I think of is, I'm seeing something forming. I'm seeing something being created. It's exciting.
Sometimes very mysterious to people and very frightening. And I know the Lord put things up there for us to see and to behold the beauty in it. And you can come out here at night and the ground is lit, that you can see your shadow and you walk around. And you can look up and watch the meteorites as they come in and just watch the heavens as they turn, which is a wonderful thing.
I am not a religious person, but I have found piecing together the history of the universe and watching other people do it, trying to understand what they say about it, a very deeply satisfying experience. I think it just pleases me to know what the past was like, how I got here, and what the future is likely to be like. And I think this knowledge is important for me to decide where I fit into the big picture
see the light? Says, Dad, I know you saw something in there.
Tonight, even 2-year-old Jenny is starstruck, though her technique could use a little work.
What do you think? Did you see it? I doubt it, but you could try. You want to try again?
By the time she reaches her father's age, who knows what visions of the heavens await
Pretty
us.
cool. He wants to get in on it, too.
We once defined our universe only by the stars that turned overhead. Technology has now delivered us into a vast assemblage of 50 billion galaxies. As we continue to probe the limits of the cosmos, we can only hope our imaginations keep pace.